So this video is on the Equation Week D-Day review. I'm getting us ready for our chapter 1.5 quest or test that we're having tomorrow. Okay. So on this, combining like terms. So you're going to add x squareds with x squareds, x's with x's, and just plain numbers with plain numbers. So let me just highlight. Okay. So x squared and x squared. Now notice I highlighted the negative in front of the 7. That negative goes with the negative 7x squared. Okay, the sign is always in front. Then I have this negative or minus 2x and this positive 4x. And I have this minus 8. Now, when I add x squareds with x squareds, they're still x squareds. You just have more or less of them. So in this particular situation, when I have 5x squared minus 7x squared, I am going to end up with a negative 2x squared. Then when I have my negative 2x plus 4x, that is actually going to be a plus 2x. And then I have my minus 8. And that's your answer. We're just combining things that are like. On number 2, we're going to distribute this 3 to both of the things in the parentheses. Then this is a minus 5 or a negative 5 that's going to distribute to both of these. So when we say distribute, we're going to multiply. Okay. So I am going to take 3 times 2x and 3 times positive 1. So 3 times 2x is 6x. 3 times a positive 1 is a positive 3. Now, again, this is a minus 5, but think of it as a negative 5. And so this negative 5 is going to distribute to my x, and this negative 5 is going to distribute to my negative 2. So a negative 5 times x is a negative 5x. A negative 5 times a negative 2 is a positive 10. Now I'm going to combine like terms. So I'm going to add x's with x's, okay, and numbers with numbers. And again, notice I'm taking the signs from in front. So a 6x minus 5x is x. 3 plus 10 is 13. And that is my answer. Okay, solving. So when we're solving, okay, let me just draw my lines real quick. So when we're solving, you want to make sure that you do the same thing to both sides. Now, this is all the different types that we've been seeing, okay? So this very first one, number 3, is going to be a 2-step problem. So the first thing I'm going to do is I'm going to get rid of the minus 7 by doing the opposite. I'm going to add 7, add 7. And so when I do that, I am going to get 4x equals 20. Then I need to get rid of the 4 that's multiplying with the x. I'm going to divide by 4, and I'm going to get x is equal to 5. And that's my answer. Okay, on 4, you have x on both sides. So we want to see if we can get x's on the same side. I would deal with my x's first. So I can either subtract 11x from both sides, but that's going to give me a negative when I do that from the 7x, or I can subtract 7x. That's going to leave with a positive. So I'm going to subtract 7x from here, 7x from here. When I do that, 11x minus 7x is 4x plus 4 equals, and on the other side, be careful, that negative needs to come down with the 12. I get a negative 12. Now we have a 2-step problem. So I need to get rid of that plus 4. The opposite of a plus 4 is minus 4. So on the left-hand side, I'm going to get 4x, and then a negative 12 minus 4 is a negative 16. Then the second step of a two-step problem is to get rid of that number in front. So I'm going to divide by 4. And I get x is equal to -4. And that's my answer. Okay, on 5. So on this one, what you want to notice is I have a lot of stuff over here on this side of the equal. Now I have some stuff on this side, but we're looking to see, do we have like things? In the blue side, I have some like things. I have a 9x and a -4x. So those I can actually combine. And so that 9x minus 4x is going to be a 5x. That just cleans up to a 5x minus 11. That's a much easier way to write that side. Now the other side, I have x and 7. I can't combine that. So now I have a situation where I have x's on both sides. I can either subtract 5x from both sides, but that's going to give me a negative with the 3x, or I can subtract 3x from both sides. I'm going to subtract 3x. Subtract 3x. And when I do, I'm going to get 2x minus 11 equals 7. Again, two-step problem. So to get rid of the minus 11, I'm going to add 11 to both sides. And I am going to get 2x equals 18. To get rid of the 2, I'm going to divide both sides by 2, and I'm going to end up with x is equal to 9. And that's our answer. Okay, number 6. So on this one, I have x's on both sides. So I am going to, and I have the same x's on both sides. So what's going to happen here is when I subtract 5x here and 5x here, those actually cancel out. Now, what am I left with? On this side, I'm left with 13 equal, and on the other side, I'm left with 13. When you have your x's disappear, see what's left over. And ask yourself, is this true or false? Well, 13 equals 13, that's true. So that means your answer is all real numbers. You can write it like that, or you can write out all real numbers. Or sometimes people will write infinite solutions. Okay, all those would be acceptable. But don't leave it as 13 equal 13. I need to know that you know what that means. Okay, on number 7. On number 7, I have these I have a lot of things I need to deal with. First thing I need to deal with is this 3, positive 3, okay, is going to distribute to both of these. And let me just emphasize that this is a positive 3, okay? I was going to try to get a color that matched. Okay, positive 3. So when I do that, I am going to end up with 2. Don't add the 2 plus 3 and get a 5. That's a no, no. Okay, so I have 2, and now 3 times 2x is 6x. 3, positive 3 times a positive 1 is a positive 3. So I'm going to go plus 3 equal. Now this other side, let's just keep it for a second. 7 plus 6x minus 2. Now I have a lot of stuff going on both sides. On this side, I have a 2 and a 3 I can combine. On this side, I have a 7 minus 2 that I can combine. So I am going to get on the blue side, my 2 and my 3 are going to add a, oops, let me highlight still, sorry. And I'm going to get a 5 plus 6x. And on the green side, I have a 7 and a negative 2, 7 minus 2. So I'm going to get a 5 plus 6x. And again, I have x's on both sides. I have 6x on both sides. So if I subtract 6x from both sides, it's going to cancel out. And I am left with 5 equal 5. And you might notice that I have exactly the same thing at this point on both sides. So when I say I have a 5 plus 6x equals the same thing, a 5 plus 6x, this is going to be a situation where both sides are true no matter what. And so your answer is all real numbers, okay? Or again, all real numbers. Or infinite solutions. I'm going to abbreviate solutions. Okay. On 8. Okay, so on 8, I am going to distribute my 4 to both of these. 4 times x is 4x. 4 times 3 is 12 equals 28. Now I have a two-step problem. I'm going to minus 12. I'm going to minus 12. And when I do that, I'm going to get 4x is equal to 16. 16. And then I'm going to divide both sides by 4. And I'm going to get x is equal to 4 as my answer. Okay, so on 9, they told us that we are solving for y, sorry for x. I'll draw my line. Okay, so on number 9, they told us we're solving for x. So what my first step is I want to get that bx by itself, okay? So what I'm going to do is I'm going to get rid of my ay. So I'm going to add ay to both sides. And when I do, I'm going to get bx is equal to, and on the other side, I get a c plus ay. Now I need to get the x by itself, so I'm going to divide by b. And I can either divide each of these separately by b, but what I would probably do for this problem is divide this whole side by b. So I'm going to get x is equal to c plus ay all over, and that is our answer. On number 10, okay, I'm going to distribute. So I'm going to distribute my 3 to both of these, and I'm going to distribute my 2 to both of these. So I'm going to get 3 times x, which is 3x. 3 times a negative 2 is a negative 6, equal. And on the other side, 2 times x is 2x, and 2 times a negative 3 is a negative 6. I'm going to deal with my x's first. So I'm either going to subtract 2x or subtract 3x. Subtracting 2x will end up giving me positive. So I'm going to subtract 2x here. I'm going to subtract 2x here. And I'm going to end up with x minus 6 equals, and on the other side, I have a negative 6. Now I'm going to get rid of the minus 6. So I'm going to add 6, And I know a lot of us panic when this happens. I get x on this side, and this cancels out. But what do you get when everything on the other side cancels out? A 0. And your answer is x equals 0. That is allowed. This is not no solution. 0 can be an answer. Okay, number 11. So in this one, we're solving for x. So the first thing I'm going to do is I'm going to get rid of the minus 2. I'm going to minus 2 from both sides. Now, when I do that, this is a negative x. And on the other side, I get a c minus 2. Now, when we're doing this, we don't want negative x. There's really like a little negative 1 in front of this, if you want to think about it like that. Okay. So what I'm going to do is I'm going to divide by negative 1. And I would do each of these separately because we can clean this up. So when I take a negative divide by negative, I get a positive. When I take a positive divide by negative, I get a negative. And when I take a negative divide by negative, I get a positive. Now, what I want you to notice happens here is I started with this and I ended up with this. And if you'll notice, let me get my mouse here, sorry. What you'll notice is this was negative, now it's positive. This was positive, now it's negative. This was negative, now it's positive. When I divide everything by a negative 1, what does that really do? It really makes, so make everything opposite. So I am dividing by a negative 1, but what's going to be the result every time is everything is going to be opposite. So when I see negative x equals c minus 2, I don't really divide. What I do is I just think, okay, everything's going to be opposite. Okay, that's going to be positive. This is going to be a negative. This is going to be a positive. Done. Okay. On the next page. Okay. So on a problem like this, this f of x equals 3x minus 2 is what we're substituting into. they want us to put -3 in. So when they're telling us to work out f of -3, that means what's going to happen is in place of your x, because this, I'm putting -3 in place of my x, I'm going to put -3 and work it out. So I'm going to get f of -3 equals 3 times -3 minus 2. So f of -3 equals a -9 minus 2. So f of -3 equals -11. You are done. Some of us are dividing by a -3. That's not f times -3. It is f of -3. And that's saying when I put in a -3, what do I get out? When I put in -3, I get out a -11. That is your answer. Okay, on 13, this is dealing with range. I'm just going to get a line to use. Okay, I'm going to get a horizontal line to use here for range, because range is how high and low the graph goes. That it's your y's, the range of your y's. Okay, so range are your y's. That's what I'm trying to find. So as I move this up and down, the lowest that this goes, the graph ends here. And if you look here, that's at a -4 for your y. So I'm going to go from -4. And then the highest my graph goes is here, which I know it's a little off the screen, but let's say that's a 5. So from -4 on my y to 5 on my y. And I'm going to write it in an interval form. And so the way I'm going to write that is I'm going to write close bracket -4, because that was the lowest of them, to 5 close bracket. Close bracket are these square brackets because it actually touches there. If it did not touch there, I would do a parenthesis. If it went up to but didn't quite reach, I do a parenthesis. We call that open bracket. Okay, now on number 14, when we want f of 1, that's saying when we put in 1, what do we get? So it's really saying 1 comma what, okay? So I am going to get my line. I am going to have a vertical line this time. And I want to go where x is 1. So if I move this here, this is where x is 1. Up and down, this whole entire line is where x is 1. Well, when x is 1, where does it touch the graph? Right here at 5. Okay, so right here at 5. So my answer is going to be 5. That is my answer. F of 1 is 5. When I put in a 1, my output is 5. When my x is 1, my y is 5. Okay, on these problems. So first thing I want to do is I need to deal with this, okay? And just to make sure everyone understands, so here I have a 3x squared, not doing that. This part here, if I was to write it out, just so everyone understands, I'm going to put it here and I'm going to put it in a second. 2x times 2x times 2x. So I have a 2 times 2, which is 4, times a 2, which is 8. X times x times x, which is x to the third. So what's happening is my 2 is being raised to the third power because I'm timesing it with itself 3 times, and my x is being raised to the third power. That's what that really means. Okay, so I end up getting an 8x to the third. Now what I'm going to do is I'm going to take my 3 times 8 and get a 24. And then when I have x to the second times x to the third, I get x to the, and it is the power of 5. And why it's a power of 5 is, again, x squared is x times x. X to the third is 1, 2, 3 of them. How many do I have total? 5 of them. So what is my final answer? 24 x to the 5th. That's my final answer. On 16, let me just clear this. Okay, so on 16, what I want to do is I want to look at my number with my number, my x's with my x's, and my y's with my y's. Now, this is a fraction, so 6/12 is really just a fraction, okay? And can I reduce 6/12? Yes, that's a 1/2, okay? So really what's happening is I can take 6 from here. And when I take 6 from the top, I get a 1. And when I take 6 from the bottom, I get a 2. That's another way to think about it. So I'm going to have a 1 and a 2. And you don't need to put the 1 on top unless there's nothing there. But I'm just going to put it here. Okay, so now I'm looking at my x's. 3 on top and 5 on bottom. So I can get rid of 3 on top with 3 on bottom. So if I cancel 3 here and 3 here, I'm left with 2. And where am I left with that 2? On the bottom. Then when I'm looking at my y's, I have 4 y's on top and 6 y's on bottom. So I'm going to get rid of 4 y's on top and 4 y's on bottom. So I'm going to be left with 2. And where are those 2 going to be? On the bottom. So I'm just going to move my y to the side. So again, since I have nothing on top, I definitely need them. But if I had other things on top, along with that one, you don't need them. And that's your answer. Okay, on 17. So on 17, first thing is I do not like that negative exponent, okay? I do not like that negative exponent. So when I have this to a negative exponent, I am going to move it down to the bottom. So this is going to be moved down here. So let me just rewrite the problem, okay? A -3, that's a normal number. I have no issue with my number being negative. I just can't have my little exponent being negative. So -3 is going to stay. My y to the 6 is going to stay for a minute. My x to the 4th on bottom is going to stay. My y to the 3rd is going to stay. Now, I am moving that x to the -2nd down. So when I move things from top to bottom, the power becomes opposite. So since it was a -2 on top, it's a +2 on bottom. So as a quick example, if I wanted to move this to the top, I could. I don't want to because it's not going to be nice. But if I move that to the top, it would have been a -4. So when I move it from top to bottom, the sign of the exponent changes and becomes opposite. Okay. Okay, so now I'm going to look at my number. Well, the only number I have is a -3. Okay, so that's going to be. I'm going to look at my y's. Okay, so because I have a y to the 6 here, I have a y to the 3. So I have 6 y's on top, 3 y's on bottom. I can cancel 3 on bottom and top. And I'm going to be left with 3 on the top. Now my x's, okay? I have on the bottom an x to the 4th and an x to the 2nd. So I have 4 x's times 2 x's. So I'm going to end up with 6 x's on the bottom. So my final answer is -3 y to the 3rd over x to the 6th. That's my final answer. So study, 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 and get ready for our test.